welcome to the House of ZK Radio, which is a focused podcast and media channel exploring everything ZK, zero knowledge. Hi everyone, welcome to the House of ZK Radio podcast. My name is Alice. I am the primary host of House of ZK Radio, and today I'm joined here with Ouyang, who is the CEO of Snarkify. Very excited to have you here today.
Thank you for having me.
Yeah, of course. I'm wondering if we can first start off with an introduction of yourself, maybe how you got involved in the Web3 space and specifically focused on ZK.
Cool, yeah. Hello everyone, I'm Ouyang. I go by Dr. Ouyang on Twitter. I'm the co-founder and the CEO of Snarkify. I got into Web3, I think, back in 2017 when I was a research scientist at Meta, at that time called Facebook. I started with crypto mining because I have a background in high-performance computing, so I'm very interested in where performance can becoming revenue or profits. That's where I get started with Bitcoin mining. And at that time, I quitted Facebook and co-founded a company called Open Mining, which focused on FPGA and GPU acceleration of proof of work. That actually built into our ZK effort. In 2021, we pivoted to ZK because ZK was picking up at that time, and we are seeing more potential of ZK applications. And our learnings in crypto mining using FPGAs and GPUs actually helped us to make many strategic decisions. For example, we are heavily betting on GPUs. We never think FPGAs was compatible for ZK workloads. We also didn't go into ASIC. The other thing we decided is we are focused on using ZK to prove useful applications. So we didn't get into adding mining related stuff anymore. Or for example, ZK mining is not something we do anymore. Yeah.
Got it. And it's interesting how you're able to apply the approaches that you had back from open mining to Snarkify today.
Yes.
Yeah, nice. I'm wondering just on the differences between the approaches or like the models for hardware acceleration. Mm-hmm. So you mentioned that you previously worked with FPGA, and then there's also the GPU-based approach, and there's ASICs as well. Mm-hmm. Can you give a comparison between these approaches and any kinds of trade-offs between them as well?
Sure. I think cost is the most important factor when you do this kind of high performance computing at a large scale, because GPUs are expensive, FPGA are expensive, and your investment in ASIC is also expensive. GPU, because NVIDIA has a very large market cap, it covers many potential applications, so they can invest a lot into the research development as well as tape out technology. That's why it achieves very good performance and pricing ratio. FPGA is on the other side because of its limited market cap. It can only afford less advanced technology node. That's why it's more expensive because less volume production, as well as more slower because of less advanced technology node. Then, other than cost, the second problem is programmability. We figured that for the same algorithm, maybe it take 1 day or two to implement on the GPU. Not the best performance, but you can do it. But if on FPGA, it probably take weeks to develop. The same thing happened during our experience with ZKPs, where our GPU implementation was quite fast. In terms of engineering effort. However, our FPGA development was take months to finish for the same problem, the same algorithm. ASIC as well, the programmability is very bad, and design a programmable ASIC is a separate challenge. That's why we are heavily betting on GPU for its low cost, accessibility, programmability. Anything that I want to compete with GPUs, I basically compete with NVIDIA. It's not competing with us, but competing with NVIDIA, you can imagine, is, very challenging.
I see. And do you project the GPUs that based approach dominating in the future, or do you see perhaps a combination of different approaches like FPGA, or as we're seeing more developments in ASIC, do you see a combination of them or more dominance towards GPU?
GPU will stay dominating until the ZK market cap really picking up, where the market is large enough to sustain an ASIC business. That's my betting.
I see. Okay. Yeah. Well, we'll see in the future where this leads us.
Yeah. It will happen, but depends on when.
Yeah, definitely. And also very curious to hear about your thoughts on ZKVM hardware co-design, because we see a lot of trends for ZKVMs really optimizing for the CPU first and then moving on to accelerators. So I'm curious to hear about your thoughts on the limitations to this approach, like first optimizing for the CPU, then moving on to the accelerators, and if there's any kind of ZKVM developers in the audience, what you suggest the approach should be when considering the design.
Okay. Yeah, the lessons we learned there is that the solution is end-to-end. So what does end-to-end mean? Let's take 2 years back. When people started to working on ZK acceleration, we started with accelerate part of the computation, aka some kernels, computational kernels. Everyone now in the ZK knows MSM and NTT. 2 years ago, when we started to participate in ZPrize, all the competition was about accelerating MSM, accelerating NTT, with GPUs, with FPGAs. There are even ASIC companies trying to build ASICs to accelerate MSM and NTTs. However, it turns out by only accelerating those 2 kernels was not enough to bring to speed up your end-to-end process. That's a lesson learned first by companies like Squirrel and RISC-0, who did in-house end-to-end acceleration with in-house GPU teams. We encountered the same kind of problem. What's the solution there? We do end-to-end acceleration for the whole proof generation process. That's what we did in the latest ZPrize, where we achieved 900 speed up. That's possible only because we move the whole computation to GPU. It's no longer between CPU and GPU, no communication back and forth, no communication between GPUs. It's just a single GPU. All the proof generation is on the same device. However, that's not possible for current ZKVM yet, because current ZKVM is still consuming a huge amount of memory that does not fit into one single GPU. Then we need to figure out how to design our proof systems and ZKVM in a way that the computation can be distributed to multiple devices, and all the computation can finish in one device without a lot of communication, so this thing can be scaled out. Then we can aggregate them in a very cost-effective manner. In this way, we can have a highly scalable, low-latency ZKVM. But for that to happen, we have to design our proof system and ZKVM with accelerators, especially GPUs or ASICs, as a first-class citizen, instead of designed for CPUs first, then ask those accelerators to speed up. That we already reached the limit of that approach.
I see. So I like how you phrased it as kind of treating it as a first-class citizen. So that should be the main priority there. I see. And relating to the proof generation pipeline, you mentioned that you're kind of addressing it as a whole. I'm just wondering about the specific like stages where you see the most bottlenecks during the proof generation, and maybe some limitations, or how ZK acceleration can address those specific bottlenecks.
Yeah, I think right now the bottleneck is apparently data movement between CPU and GPUs. Because let's take the big field approach, for example. The memory consumption is easily 200 gigabyte and 300 gigabyte. Imagine to process this amount of data, you have to move this amount of data over PCIe bus to your GPU devices, compute, maybe move them back and forth multiple times to finish the whole computation. No matter how fast your GPU compute is, it's bottlenecked on the data transfer. So what we observed right now is that we are not even saturating the GPUs yet. So we have maybe idle cores or idle GPU times that's not fully utilized because we are waiting for the data to transfer. I think going forward, we have to resolve that data movement bottleneck. Otherwise, even if we build very fast ASICs, it won't help, because still the ASICs will wait for data transfer from the CPUs.
Got it. And that's one of the main reasons why like ZKVM should really focus on the hardware acceleration first, as opposed to just building on CPUs and then moving on towards
exactly.
Got it. Okay. That definitely makes sense. Also wondering about your thoughts on the different stages relating to like ZK acceleration. What stage do you believe we're currently in, and what does the end game look like for you in terms of reaching an optimal part for hardware acceleration?
That's an interesting question. I think this is not my idea, but I think it's quite promising. the end game is probably like, imagine a CPU device. It have 1% of the CPU chip area that is doing the typical CPU workload we are doing now. However, you have 99% of the GPU area doing ZK compute. In that way, every instruction computed on that CPU device is ZK verified automatically. That may be the end game of our future computation. Like all the computation are verified automatically from CPUs off the shelf from Intel, AMD. That's everything's ZK verified automatically. Where are we now? Right now, we are really constrained by our market size. So the core constraint is not actually teams like us, like how fast we can build our GPU acceleration or how fast we can build our ZKVM. We are not actually seeing a lot of demand so that we can build faster technology to serve those demand. But it's a chicken and egg problem because like we don't have, once we make the VM faster, we may unlock new applications so we can create more demand. I think we need to like make this like health spiral or flywheel so that we improve the performance, get more applications, and more applications can sustain better technology.
Got it. So there's also that bottleneck relating to markets and also the demand that comes with it.
Yes,
I see. Yeah. And I'm also thinking like when we speak about the ZK endgame, a lot of people also see real-time proving being incorporated in it. I'm just curious to hear your thoughts on what real-time proving specifically means to you and what sort of applications can it bring, just both for general ZK applications and on the hardware acceleration side as well.
I think real-time proving is a term defined by Vitalik and Justin Drake, such that the proof generation time is within the block time. In this way, every layer 1 block, once it's produced, you can prove it before the next block was produced. That means every layer 1 block can be proved immediately. That can unlock a lot of interesting applications. For example, all the layer 2 rollups, they can settle their blocks with ZK on the layer 1 block within 12 seconds, the average block time, so that you can do cross-chain communication and automatic communication and settle within the same Ethereum block within 1 block time. So that's unlock a lot of potential of interoperability. I think that's solves the fragmentation problem right now across all the layer 2s. That's a huge thing. I think right now all the large ZK chain clusters are trying to solve this problem, including ZK-Sync Elastic Chain, or the Scroll, SDK, etc. I think this is the most exciting area to work on right now to enable interoperability, especially real-time interoperability between the rollups.
Yeah, definitely. And there's also a lot of solutions that are trying to implement this without having to design it like an actual bridge, which we all have some like security assumptions involved there. So that's definitely a trend to enable this further interoperability. Yeah, I see. And also very curious to hear about, on Snarkify's side, how you guys are helping with the developer experience. We see that there's like a lot of challenges today relating to developer adoption, especially when building ZK-based applications, just because it's so difficult and there's a huge learning curve attached, and even things like costs and the time for generating these proofs can be quite costly. So I know that Snarkify has quite a few developments on the developer experience side. So for example, you guys have a few SDKs, other tooling as well. So wondering if you can elaborate more on how you're specifically helping the developers.
Yeah, it's quite interesting. We kind of took a very unique approach where we emphasize developer experience from day one. However, it turns out we are a little bit ahead of the market. Like our Elastic Prover, where you can deploy your code on GitHub and get it automatically deployed on our platform, was ready maybe a year ago. But even like until recently, it's picking up because when we finally integrated those Elastic Prover with chains in production to provide like production proofs for them. And on the performance and cost side, we did a lot of acceleration work from day one, and until recently, like those projects has production deployments started to really care about performance. People are reaching out to us asking, well, we have this either client-side proving application or server-side proving application. It's really expensive. How can we help them to improve the performance and cut down the cost? I think this is a good sign for us and for the industry, because when they were at development stage or R&D stage, they don't really care about like the performance or cost, because it's R&D and it's not in production. Right now, people started to care about cost and performance. That's a sign that ZK is getting into production. So I think our field, our industry is progressing, and turns out we are serving that well. Being a little early is a bit painful, but now we are good.
Yeah,
in a good position. Yeah.
And we will definitely see more mainstream adoption coming soon. Very excited for that stage. Also curious to hear more about Snarkify's prover network, and I know you guys also really try to emphasize on decentralizing it. So very curious to hear your opinions on the advantages and benefits that come with decentralizing the proving network, and also some limitations or bottlenecks that may come through.
Yeah, decentralization is an interesting topic. We again took our opinionated approach. We didn't emphasize decentralization from day one. We emphasize production and adoption from the first place. So I think we need to answer the question that why do our customer care about proof generation decentralization? If we have already built a centralized service that can provide low cost proof generation, high scalability, and reliability, so what are the other value add for decentralization? I think right now our position is like decentralization can further cut down your proof generation cost, because you have a decentralized supply, can reduce the cost. The other side is real-time payment, because right now all the proof generation actually happen in an off-chain way. It's in a Web 2 way. You provide APIs, then and they send proofs to you. I think going forward, we can use on-chain payment to enable real-time payment instead of monthly bill like Web 2 payment experience. Yeah, I think that's the main value add. Then there are other potential applications that could be unlocked. For example, if the majority of the chains are settling on the same network, like verify all their block proofs on the same network, we could potentially enable some interoperability between those chains, because two blocks from different chains are settling on the same chain. That's one possibility. But I think most importantly, we are spending a lot of thinking or effort on figuring out what's a value add here. We don't want to do decentralization for decentralization.
Yeah, just because that's a common trend that you're doing it. You want to see what additional value that can provide your users. Got it. Yeah, and also very curious to hear, because I know that you guys have also integrated with Scroll for the proof generation as well. Very curious to hear about what drove that decision and why specifically you chose the Scroll ecosystem to do that.
Yeah, that's an easy choice for us because we are an adoption-first company. Whoever we choose to work with, they must have production proof generation volume at scale. So they have to have production deployments, and they also have to have significant volume to make it the case interesting. Scroll, as one of the largest ZK rollups, apparently has the largest proof generation or ZK deployments right now. Also, they are the first actually decentralized their prover network. They are the first network ZK rollup that allows third-party proof generation providers to plug into the network and generate the proofs. I think Scroll is quite advanced than their competitors on the proof generation side. Their proof generation cost is quite low because of third-party proof generation providers as well as off-cloud proof generation. But other projects are picking up. For example, ZK Sync, right now they are decentralizing their mainnet as well as their elastic chains, are allowing third-party proof generation providers. Aztec is doing the same thing. So we are seeing more demand and more projects decentralizing their proof network.
I see. Yeah, it's very always interesting to hear about like different projects' perspectives on why they chose to say like build on a specific ecosystem or integrate with it. So yeah, good to hear those reasons. And also, I did see in your background that you do have some like experience and background within performance optimization. So I was very curious to hear about your perspectives relating to benchmarking. So benchmarking, like even like for example with ZKVMs, has been a pretty controversial topic on how we can enforce like standards towards benchmarking and ensure like transparent, fair results. So I'm wondering about like your general opinions on how we should approach this benchmarking process and to any kinds of best practices in order to ensure that it's reproducible and it's fair, it's transparent.
Yeah, I think short answer is like reproducible is the key. So no matter what you do, you have to provide the code, the full setup, and like how do you run the experiment, how to measure it, how the data was processed. This for someone like me, I have a like academic training of performance evaluation and benchmarking. This kind of built into my DNA how to do this whole thing. However, like people tends to benchmark in a way favors their product. That's how they do it, and sometimes they think it's fine because they think every other people is doing that. I think to do a really fair evaluation, you have to be like subjective and open source your code. Tell people what's your hardware settings, how did you run the experiment, what's the workload. I think the best practice is already there. We have been doing benchmarking for AI, for computer system, database networking all the time. The thing is, people in our field has to adopt the best practices from all the previous work and not creating something new, trying to announce we are 20 times faster than you, and suddenly the other side announces similar things as well. Yeah, we should do something more concrete and can stand the test of time.
So really valuing the reproducibility from there, and not having situations where we're like comparing like apples to oranges. Like, for example.
Exactly. Regarding apples to orange question, they need to disclose all the assumptions. That's quite important because, for example, when your VMs has precompile where the other side does not use precompile and you compare performance, that's apparently not fair. People should declare that instead of just saying, well, we're faster. That does not make sense.
Being transparent with the assumptions.
Yes, that's very important.
Yeah, got it. And also curious to hear, just on the Snarkify side, I saw that you guys, what stood out to me was that you developed your own folding framework, Plonkish-based folding framework called Sirius. So I was wondering about the motivations for designing your own frameworks there and what that enables for developers.
Yeah, I think that's we call it a big bet. We want to lead instead of just follow. So 2 years back, when folding get picking up, we just our ZK projects just get launched. We want to pick a frontier area, try to work on, and to create something valuable for the community. I think folding was like buzzword there, so we started to work on folding. Our CTO was quite interested into that, and because it's quite promising to use folding to actually fold ZK EVM circuits. That's a North Star for us. We want to use folding to fold ZK EVM circuits and trying to achieve better performance than the KZG-based proof system. I think the turns out we are the only folding system that can fold Halo 2 circuits directly. Because like other folding systems are R1CS based. For example, Nova, they use R1CS. You cannot use it to fold Halo 2 circuits. Right now we have something like a serious open source library can fold Halo 2 ZK EVM circuits end to end. Unfortunately, the field is moving into smaller fields, like Plonky 2, 3-ish FRA based protocols. So that's quite of a learning there. But still, we did a great work there. If you look at the research and engineering, but the bet turns out to be not to be the ideal case for us. But still, it's quite good of learning, and we hope the open source library could benefit the community too.
I see. Yeah, and just curious also about like what implications will bring once it's integrated into Snarkify Cloud, and also if you could discuss about the possibilities of this framework being applied to, say, outside of the Snarkify ecosystem, what that may look like.
Yeah, I think this open source library and the folding work is quite independent with our core product and platform. It's more like a research and development effort. We didn't target it to deeply integrate into our existing product line. However, we did try to work with Scrollside, trying to fold the ZKVM circuit and trying to compare with their production proof generation cost. We believe folding-based approach could be more efficient than the current Halo 2-based proof system. However, it's not competitive compared with an FRI small field approach. And also, we actually need to rebuild a folding-based ZKVM to make it more interesting. So because the industry is moving away from manually written circuits to ZKVMs. So yeah, this is more of a research effort, and we hope other people could build on top of this instead of production effort.
I see. So there's like its own kinds of limitations, bottlenecks there, but then also cases where it may be like optimized or great for a specific use case.
Yeah, it's like learning from trial and error.
Yeah,
I see. We are exploring.
Yeah, always good to be in the exploring kind of research phase.
We always have that arm exploring stuff.
Yeah, I think that's really important. Nice. And also very curious, just scoping out a bit, very curious to hear about your predictions for the future of ZK. So where do you see it evolving in the next 5-10 years, and what is that kind of end goal, end vision for ZK? What does that look like for you? Yeah,
I think in 5 years, I'd like to see ZKVM get mainstream. I think ZKVM is quite an important technology where application developers no longer need to care about what is ZK. They can just write Rust code and get verified. I think the 10 years vision is like ZK should outlast blockchain, becoming a technology that's more important than blockchain, because ZK is applicable for all the traditional computation forms. It can be used anywhere in finance, in healthcare. That's what I'm looking forward to see. So I have the patience to stay in this industry for the next 5 and 10 years to see ZK really get adopted. I think that's why I picked ZK in the first place. I want to see that to happen in the future.
Yeah, and even being adopted beyond, say, blockchain ecosystems to those real-world applications, as you mentioned.
Exactly.
So very exciting for that to come soon. And hopefully we'll see some more developments in the next few years.
We'll build that future out.
Yes, definitely. And just as a last question before we close up, I'm wondering if you have any sort of advice that you want to give to the audience, or if there's any kinds of announcements you'd like to make on Snarkify's behalf.
I don't typically give advice to people. What kind of advice to give?
Maybe just some takeaways that you've had from this conversation. Like our audience, we have a lot of developers, we have a lot of people who are just learning about ZK. We have some people who are also doing research in ZK. So it may not necessarily have to be strict advice, but perhaps some takeaways that you've gotten or some learnings that you've had.
I see. Got it. I think I have something to share. I have an engineering background. I think when we are working on new technology on ZK, I think we need to pay more attention to where are the applications. So it happens inside our company because we are researchers and engineers who get passionate about technology. So we started to, let's build this, let's build that. Then as a CEO, I need to come out and say, what's a potential application? Where can we use it? So I think the engineers cannot just answer, if we build the technology, people will use it. That's not true. You for a technology to get adopted, it's more like a technology market fit. It must have some area that could use this technology. You need to think that before you start to build out this thing. I think that's our learnings there.
And I like how you kind of phrase it as a technology market fit. So deciding what sorts of applications and use cases this can be enabled before start building it. Yeah, nice. But yeah, I really enjoyed our conversation overall. Thank you so much for joining, and really liked hearing about your thoughts for ZK hardware acceleration in the future, and then what you guys are currently building at Snarkify, and also the Sirius framework. So really exciting developments here, and thank you so much for joining us today.
Thank you for having me, and thank you for everyone.
Yeah, thank you.